We tried to identify some specific errors that get made, and this example 4 here did a pretty bang-up job of exposing some of those errors. We got to be really careful with the minus signs. In math, minus signs are often just kind of there. They make the number negative, and they don't have a lot of meaning otherwise. But in physics, the stuff that we do this year, and especially the stuff that if you go on to Physics 12 and you start working in multiple dimensions, these minus signs are going to become really, really important. Well, they are important in this semester. They will continue to be important next semester. They have meaning that we'll talk about in a little bit. So we've got those examples that I went through. There's 2 more sets of examples we're going to go through. Flip the page. Rather than substituting in values and solving things, we're going to go through rearranging formulas. An exercise that students everywhere seem to love. The rules are the same. When you're substituting and solving versus when you're isolating, the rules are exactly the same. The only difference is when you're rearranging a formula and you're isolating for a variable, things don't necessarily get simpler. Like there's not numbers that resolve themselves. It's just going to be a bunch of letters that just get shuffled around and still look gross. But as long as you follow the mathematical rules, nothing's going to change. So if I've got F equals MA, I want to solve this thing for M. If there's no mathematical symbol given, then what's the operation going on between the M and the A? They're being multiplied. So if these two are being multiplied together, and I want to get rid of one of them, what do I have to do with the one I want to move? I have to divide. The opposite of multiplication is division. Whatever I do to one side, I would do to the other. It's the exact same thing we were doing yesterday when these F and A had values. Now they don't. They just have to stay where they are after we've done the operation. So on the right-hand side, they're going to cancel. A over A is gone. And we're just going to get that this formula becomes M equals F over A. And like I said, I'll say it again, the only difference being nothing is getting resolved here. But otherwise, it's the same procedure. So let's make it more interesting. Let's get C by itself. What's the first thing we have to do to get C alone there? By? We've got M times C squared. So to get the C alone, the first thing we have to do is get rid of the M. The way I've started trying to teach this to my grade 9s, because they still struggle with, yeah, but what order do we do things in here? I go back and I reference this. If you are simplifying a whole chain of numbers, you do BEDMAS. BEDMAS, and you do it left to right. If you're calculating something and you're given an expression, this is how it behaves. When you're trying to isolate for a variable and things aren't getting cleaned up, I've started telling my grade 9s, well, it's just SAMDEB, which is BEDMAS, but backwards. You deal with any addition or subtraction, you deal with any of the multiplication, then you deal with the exponents. That multiplication by M needs to go away before we can touch that squared. So dividing both sides by M is going to give me that C squared is going to equal E over M. Now, I don't want C squared, I just want C. So what's the opposite of squaring something? Square rooting something. So we're going to square root both sides. On this left-hand side here, the C squared, the square and the square root cancel. Those are opposite or inverse operations. So C then is just going to equal the square root of E over M. And it looks a little gross, just because there's no numbers to clean it up with. In 3, if I wanted to get G by itself, what would I do? Ooh, if I moved the G to the, if I moved the G, how would I do that? Why are you walking that back? Why are you walking that back, Emma? Why is that a horrendous decision? Yeah, because then you're putting it in the denominator. There are fewer things worse than putting something you want to get out than putting them in the denominator. So then what is your best first option? Sorry, Henry? Henry, you said something. I saw your lips move and you made eye contact with me. No, not a sound came out. I thought it was a whisper. What is happening with the mg and the h? They're all being multiplied. So if I want to get rid of any of these pieces, what am I going to have to do to get rid of them? Yeah. Yeah, I can divide in one step by all the things I'm trying to get rid of that are multiplying there. So because I've got m times g times h, if I want to leave g alone, I can just multiply both sides by m and h in one step. That's a b, not an h. There's an h. So my m's will cancel there, my h's will cancel there, and we're just going to be left with g is equal to EP over mh. How about number 4? What would I do? I want to solve for m. Getting progressively more interesting. How would I get m by itself? What's happening to the m? Grind open today. I'm very excited. What is happening to the m? Someone. By what? It's getting multiplied by the half and it's getting multiplied by v squared. So I want to leave m where it is and I want to move those two things. Multiplying, what's the opposite of multiplying by a half? The fractions are where things get interesting. Yeah. Oh, sorry, Colden. Yeah, multiplying by 2. Yuli, is that what you were going to say? So if I multiply both sides by 2, that's going to get rid of that half. So that's going to cancel. And now I've just got mv squared. Well, that's just m times v squared. So we get the m by itself. You can just divide both sides by v squared. And we're going to get that m is going to equal 2ek over v squared. Number 5. There is no uppercase p. Well, this is the wrong letter. Solve for lowercase p. What do we do? Just different kinds of isolating for variables. This one brings in something that the previous examples didn't. What's new about this one? The addition and subtraction. So as I've been teaching my 9s, if it helps, when you're isolating for a variable following this SAMDEB or just BEDMAS backwards, you want to deal with the addition and subtraction first. So what am I going to have to do to get rid of the 7d and the 8x? Because that has to happen first. Which subtract by both of them. The 7d here is positive, so I'm going to minus 7d. This 8x is positive, so I'm going to minus 8x. And I'm going to get that mf, and I'm going to do the same thing to this side, minus 7d minus 8x equals what? Yeah, see that minus sign, students drop all the time. The sign always goes with what comes next. So even though I've gotten rid of the 7d and the 8x, that negative needs to remain with the 3p. This stays together. And then to get p by itself, because the negative 3 and the p are being multiplied together, we want to make sure we divide by negative 3. The reason I go over examples like this is because What's the mistake you think students are going to make here? Rather than dividing by -3, what do you think they do? They do what? Yeah, they add 3 to get rid of the 3. The -3 and the p are being multiplied, so we got to divide the -3 out. So p is going to equal mf minus 7d minus 8x all over -3. Cool. 3 more. It gets easy again. Number 6, I've got v equals d over t, and I want to get d by itself. What do I have to do? What is happening to the d? Yeah, it's being divided by t, so I want to undo that. Multiply by t, my t's are gone. Whatever you do to one side, you have to do to the other. So d is going to equal v times t, which I'll just write as vt. Number 7, let's solve this thing for a. There's a lot there, different letters going on all over the place. How do I get a by itself? You want to start by multiplying by 2 to get rid of the half. While that is technically an option, you got to be really careful how you go about it if that's the first step you want to make. We could do it. To make your life easier, though, Lachlan, do you want to do it that way? Should we try it that way, or do you want to try it? You know what? Let's do it Lachlan's way. Here we go. You know what? Lachlan is not the only one who was thinking it, and I see it all the time. So let's go about it Lachlan's way and see how this thing plays out. Lachlan said, I want to get the a by itself. Let's multiply by 2 to get rid of the half. Okay. If you do that, what needs to get multiplied by 2? Obviously, this is going to get multiplied by 2. What else needs to get multiplied by 2? The d needs to get multiplied by 2. And what else? Because this is one long, this right here, the half at squared, this is one long, just this times this times this. So if you're multiplying the half by 2, that covers this whole term. What isn't covered is what? The VIT, this guy here. If you're going to multiply one term by anything, you have to multiply every term on both sides by 2. So by introducing that, now we've multiplied a 2 on there. Here it's going to cancel, and we're going to get 2d equals 2VIT plus AT squared. Now continuing with Lachlan's example here, what's our next step? Oh, someone whispered at Kale, was that you? You want addition? What do you mean addition? Okay. So are there things being added here that we can get rid of? The AT squared is being added to the VIT, yeah. We want to get a by itself, so we want to leave the a where it is if we can, and move everything else over. So if we're going to deal with, if Sam Deb says deal with the addition first, we're already going out of order here by multiplying by that too. But that's okay. You want to deal with the addition? Say, okay. So what's the opposite of adding to VIT? Subtracting it. So let's minus both sides by 2 VIT. And you're going to get 2d minus 2 VIT equals AT squared. And our last step to get a alone is to do what? Divide by t squared, and I have to do that to all of both sides. Here it'll cancel. So I'll be left with, if we did Laughlin's step first, it would look like 2d minus 2vit all over t squared. It's not pretty. There's nothing wrong with it. Now let's go back over here. Kale said, well, we're doing SAMDEB. Okay, well, if you're following SAMDEB, if you're dealing with that first, instead of getting rid of the half, what would have been your first step if you're doing it this way? This way. If you're reversing the bed mass, Emma, what would have been your first step? Yeah, taking away the VIT. So if you do that, we're going to take away VIT. We're going to do that to both sides, and we're going to get D minus VIT equals 1/2 AT squared. And then to get rid of, or to get the A by itself, what can we do? Divided by T squared. And now I've got the half to deal with. Multiply by 2. When you do that, you need to make sure that you're multiplying the entirety of the other side by that 2. And so you're going to get something that looks like this. You're going to get A equals 2 D minus VIT all over T squared. Do you guys see how this and this are actually the same thing? What's the one step I could do to make this expression look like Laughlin's expression? Yeah, what's it called when you put it in? Starts with a D. Distribute, yes. You could multiply that in there, and then we get exactly what Laughlin got. So, I mean, the way Laughlin suggested getting rid of that fraction first absolutely worked. The only thing you have to be really, really careful of, if that's going to be your first step, is that middle term right there. That's the thing people always forget when they get rid of the fraction first. But there's more than one way to isolate for a variable, as they say. That's not the turn of phrase. The turn of phrase is a lot grosser and darker. Does anyone know the phrase I'm referencing? No, clearly it's gone. The phrase is there's more than one way to skin a cat, which is kind of horrifying. Okay. One more. I want to get VF alone. What do we do? Don't just wait for other people to say something. Think about what would you do? There's a couple options here. Yes, Yuli. Whoa. Okay, hold on. You're dividing by t, you're multiplying by 2. Yeah, and then you said you're going to subtract something. I think you're absolutely right. I'm going to slow that down a smidge. You're absolutely right. Because we're multiplying here by t, we can divide by t. Whatever you do to one side, you got to do to the other. That'll cancel here. And the division can get dealt with in the same step. Because we're dividing this whole right-hand side by 2, I can multiply both sides by 2. That'll cancel there. And we're going to get 2d over t equals VF plus VI. And then you said that you're about to say, before I interrupted you, that because these are being added together, you subtract the VI. That'll cancel here, and you're going to get VF equals 2d over t minus VI. That's not the only way to do this question. I want to show you one other way. VF plus VI over 2 in brackets times t. Okay, one totally acceptable way to do this question. The other way we could do this question is if we want to get at something buried inside a set of brackets, distribute in what's on the outside, and then those brackets disappear. So if you distribute in that t, what you're going to get is d equals vf times t plus vi times t, all divided by 2. This is another totally acceptable way to do this. Now the next step is going to be to multiply both sides by 2. So we're going to get 2d equals vft plus vit. We're going to subtract both sides by vit. We'll get 2d minus vit equals vft. And before, when we divided right away, now our last step is going to be to divide all of both sides by t. And so what we're going to have here is that vf is going to equal 2d minus vit all over t. And these two expressions are actually the same. Two totally different ways to approach it. The end result is, in fact, the same. Comments, questions, concerns about what I've done? Don't worry, I'm going to let you practice this in a sec. I know we're right after lunch. I should stop talking soon. Okay, last thing. Hands up if you're in Pre-Calc 12 right now. Is Kai the only one? Kai might be the only one. Okay. There is something that we're going to do a bunch of this year and next year. That is, I mean, it's kind of similar to the two things that we've done where we've substituted things in and isolated for other and rearranged formulas. It's going to look an awful lot, Kai, actually like what you're doing right now in Pre-Calc 12, the transformation stuff. One of the things that we talk about all the time is how do things change if we make specific tweaks to certain variables. I'll show you what I mean by an example here. So I've got the formula F equals MA. At this point, this formula means nothing. Or it might mean something to some of you, but as a general rule, you may not have seen this before, and that's fine. The question is, what happens to F if we decide to double this value? And so being able to think about the implications of some of this algebra are important. So if F equals MA and I just decide to double the value here for A, what's that going to do to the whole expression? The way we handle this is we actually go ahead and plug that in and see what happens. So if I double A, doubling something is the same thing as doing what to it? What's the mathematical operation? Timesing by 2. So what we're going to do here is we're just going to replace A with 2A. If I double this thing, and we're going to say, okay, well, this F here is some new force. So I'll put the little subscript word new there. The new force, or the new F, is going to equal M times 2A. And what we do when we do stuff like this is we just rearrange this expression here on the right-hand side. If you were going to write this out the way it should be conventionally written out, following the rules of math, what would this thing look like? What should this thing look like? Where should that 2 go, Emma? Where should this 2 go? Or what were you going to say? Don't say that. You might not be. It's not as wrong as you think it is. We're only, that word distribute implies that we have things being added or subtracted in here. We don't. But yeah, we're just going to multiply the M with the 2A together and write it in the correct order. So the correct order is that coefficient should go where? Say the word, Kaylin. At the front. And the MA comes after. So this new f is going to equal 2 times MA. But if you look at where this comes from, what is this? What did we say MA was equal to earlier? We said it was equal to F. So this new F, so then F new is actually going to equal 2 times this is just going to be our original force. Oops, sorry. So if I double the acceleration, if I double the value for A, what is the implication here for our value for F? It's going to be 2 times as big. So this is a simple example. The same thing is going to follow, relatively simple example. The same thing is going to follow through here. If M decreases by a third, so if what's that going to do? Well, what does it mean to decrease? So let's go through it. What does it mean to decrease something by a third? Is that what it means? You're decreasing by a third. How big is M if you took a third of it away? The language here is screwy. It's 2/3. If you decrease something by a third, now you are 2/3 of what you were before. And that's the way you need to think about these things. So what I'm going to do then is I'm going to replace M with 2/3 M, and nothing's happened to the A. And this is already kind of written in this order we need it to be in. This is just going to be 2/3 MA. So if you decrease, and this piece right here is just going to be F. So if you decrease the M by a third, what's the effect on F? It's 2/3 of what it was to start. And it's a different way of thinking for a lot of you. I recognize that. How do we feel about this stuff? Is it wildly uncomfortable? Kind of, sort of? Okay, I'll do 2 more examples and I'll let you play with it. Drop down here to the bottom one. It is just getting a handle on what the expression's asking you to do and then plugging those things into the appropriate spots in our formula. So here we go. We've got this expression. This one, again, doesn't necessarily mean anything to you yet. It will. We'll look at it in chapter 3. But here's the formula. F is equal to big G times big M times little m divided by d squared. And whatever we're asked about here is what we're going to start replacing these variables by. So if d doubles, that means I'm going to replace d with 2d, and I'm going to shove it into this equation here. So what I'm going to get here is that F is going to equal the G, the M, and the M don't change. But I want to replace D. Now, if you remember what we did yesterday, when I was having you substitute things in, my recommendation was to throw a set of brackets down and then place the new thing inside there. And this is where it's going to get really important. As soon as we're dealing with exponents, that's absolutely necessary. That 2D is going to go inside here, and that squared is going to remain outside. And now we just use our exponent laws to move some stuff around. The G, the M, and the M haven't changed. But my exponent laws say if I've got something inside a set of brackets being multiplied together, and I've got an exponent on the outside, what does this exponent do? Sorry, Kale? It distributes in, you betcha. So it's going to go, the squared is going to go on the 2, and the squared is going to go on the D. 2 squared is And d squared is just going to be d squared. But then, if you take a look at this formula and this formula, this piece is just the original value for f. So what happens to f if you double the value you plugged in for d? After all the algebra is done, what's the effect? Well, it's the same as if I took my original f and did what to it? Someone say something. Just read what's happening. Ray, read what's happening. It's getting divided by 4. So if you double this value that you plugged in down here, the end result, because this thing's being squared, the end result is that f is 1/4 of what it started as. We'll do a bunch of this over the course of the semester, and you'll get more comfortable with it as we go. But I think at this stage, I need to set you free to work on some stuff. And I'll walk around and help where necessary. So, we'll let this ruminate. I want you to flip the page and take a look at this. This page here. Math review formulas. I want you to do all of it. I don't want you to cram it onto this page. So either the COIL books that I had, whether you chose to grab one or not, are an option for you still. Your own paper, if you just want plain paper, I can get and hole punch it. I can get you that too. This is what I want you to work on. I'll walk around and help where needed. It's a review of solving formulas, isolating for variables, and then some substitution problems down there at the bottom. Let me know where I can help on your market set giver. That's amusing.